Then comes the layer that turns chips into usable capacity, the cloud and the data center. This is where the AI story becomes a capital allocation story. Microsoft reported nearly $32 billion of capital expenditure in a single quarter in fiscal 2026, much of it tied to GPUs, CPUs, and data center infrastructure. It said its AI business had passed $37 billion in annual recurring revenue and, on its April 2026 call, expected roughly $190 billion of capital expenditure for calendar 2026. Meta reported more than $31 billion of capital expenditure in the second quarter and guided to between $130 and $145 billion for the year. Alphabet earlier guided to $175 to $185 billion of 2026 capital expenditure. Amazon said its second quarter AWS business was running at a $169 billion annualized revenue rate, while both its AI and custom chip businesses had passed $25 billion annual revenue run rates. These figures are not directly comparable. Accounting definitions and periods differ, but together they show the physical reality behind the software story. AI scale requires land, energy, servers, networking, financing, and years of construction. The model may be digital. The moat can be made of concrete, and where that concrete gets poured matters. The United States has enormous advantages in hyperscale cloud, capital markets, and technology platforms. For Europe, the issue is bigger than regulation. European industrial companies, banks, insurers, automotive groups, and engineering businesses will consume enormous amounts of AI. The strategic question is whether they become mainly customers of infrastructure built elsewhere, or whether Europe can build stronger control points of its own. Asian economies sit closer to many of the semiconductor and electronic supply chains feeding the build-out, while also building their own AI capabilities and infrastructure. And in energy and capital-rich markets, another question is emerging. Can access to electricity, land, and long-duration investment become an AI advantage of its own? AI, therefore, creates a new kind of geography. Not simply where the software company is headquartered, but where the chips are made, where the electricity is available, where the data can legally sit, where the capital comes from, and where the customer ultimately runs the workload. This is why winning the model race is not necessarily the same as controlling the economics of AI. A model needs somewhere to run. It needs capital to train and serve. It needs developers to build around it. And it needs distribution to reach users. OpenAI. I put the point unusually clearly in 2026. Meeting AI demand requires compute, distribution, and capital. That sentence could almost be used as a map of the modern AI power struggle. Google can connect models to Search, Android, YouTube, Workspace, and Cloud. Microsoft can connect models to Azure, Windows, Microsoft 365, GitHub, and enterprise relationships. Amazon can connect AI to AWS, custom chips, and an enormous base of cloud customers. Meta can push AI through platforms already used by billions of people. The model is important, but distribution decides how often the model gets used and where the revenue can appear. And this is where geography meets distribution. A model does not enter every market through the same door. In one country, enterprise software may dominate. In another, the smartphone may be the main access point. Somewhere else, a local cloud provider, regulatory requirement, or national language model may matter more. So the global AI race may not produce one universal winner. It may produce different control points in different markets. Watch the full documentary on Lessons Untold.